Hello everyone and welcome to this video of ZAHNER. This is Siddiq. Today in this video we are going to talk about the IE scans. For this we will hover our mouse on IECV icon and this will open the sub icons, and here we will choose I/E icon. Here we can measure the current voltage curves. As you can see here that we can follow a general voltage behavior. For example, I can go from 0 to 500, then I can come back to -100, and then I can go back again to 100. So it is up to you how you want to change the voltage. If you want to measure IBE curve only between two data points, then you can set the third and fourth data point the same value as the second one, and this will then remove these values and you will have only two data points. Okay, now if we look here, we have scan mode button, and when you click on scan mode you have three different options of scan: steady state sampling, fixed sampling, and dynamic scan. Now to understand these, we have to look how a potentiostat apply a voltage. Here I have a voltage curve, so we are going from one voltage value to another voltage value, so this is a linear voltage change with time. Now when we define in a software that go from 0 to 500 millivolt, for example, do the potentiostat change the voltage analogically, or do the potentiostat change this voltage with small steps? So do we have this straight line or do we change the voltage in small steps? Well, in this digital world, potentiostats use the second option where the voltage change occur in small steps. And now here I'm showing very big steps, but in reality they are small steps, so you can have few microvolt per steps. Now let's look at these steps in detail. So when I go from 1 voltage, so let's say this is 0 voltage and this is 20 microvolt. So when I go from 0 in no time to 20, how does the current change? Well, as soon as I increase the voltage, I see a very sharp current peak, and then with time the current starts to decrease, and then comes a time when the current somewhat stabilizes, and then with the next step we have another peak. Now we should ask ourselves one question: where should we measure the current? I have here 3 sample data points marked with stars. Depending upon which current measurement I take, I can have different kind of current voltage curves. And this thing we can define here in the scan mode, that where you want to measure your current value. So the easiest of these 3 options is fixed sampling. So let's start with that. In fixed sampling, you just define a time after which the measurement should be done. So for example, here default value is 1 second. That means the potentiostat will increase the voltage and wait for 1 second and then see whatever the current value it is. It will record that, make the next step, wait 1 second, whatever the current value is, record it, and so on and so forth. So this is the easiest thing. And here the voltage step is defined by this value. So here you can also make very small steps. Now the second mode is steady state sampling, and as the name suggests, you can define the steady state in your sample. So for example, when we apply the voltage, we have this huge currents, and now the current is changing very fast. We are not in steady state, and after some time the current change is very less, and you can define that here. So default value is 1 nanoampere. That means when the current change is less than 1 nanoampere per second, then take the value. You can give here 1 milliampere, 1 microampere, whatever is steady state for your sample. You can define this absolute value here, or you can define this value in percentage. To understand more about these data points, just right click with your mouse on these data points, and this will automatically open the IE manual where these values are properly defined. So you have an absolute and a relative current tolerance, and this defines where the current measurement is taken. Now it could also be that you were very optimistic while defining these values, and then this value will never reach. Your current change is always higher than your defined threshold. In this case, we use this maximum time delay. So if after this maximum time the tolerance is not reached, the system will take a measurement and move to the next step. So this is the second mode, that is the steady state sampling. With the steady state sampling, by giving a current tolerance value, you are mostly measuring your current in this range, and with this you ensure that you are measuring Faradic response and this non-Faradic response is not measured. The third option is dynamic scan. And in this dynamic scan, what the potentiostat basically does is that it integrates the whole peak and it measures the whole current under the curve. So you just define your scan rate as we were doing with linear scan in the last video in polarization, and you define your voltage values where you want to go, and then you can start your measurement. Now here, if you know what are the current ranges for your samples, for example, if you know that from 0 to 500 millivolt your current will not increase more than 1 milliampere, then you can put here the appropriate current ranges. Last but not least, we have here the ohmic drop correction. So if you have series resistance in your system, you have high electrolyte resistance, you can remove the effect of this additional resistance from your IE scan. If you know your series resistance, just put it here. If you don't know this, click on this data box and then insert a star and click OK. And with this, the potentiostat will measure the series resistance for your sample. As a general rule of thumb, you should give here 90% of the total resistance. So I have 10, so I will put 9 ohm. And then I will click OK, and with this you can start your measurement and the ohmic effect will be removed from your IE curve. When you activate the ohmic drop correction, this correction is not done in your measurement data by the software, but actually done by the potentiostat with the analog positive feedback loop. So now we have defined our voltage values, and you can also choose an appropriate scan mode. And then you can choose if you want to have an ohmic drop correction or not. If you don't want to have it, just click here and provide 0. And then the ohmic drop correction is deactivated. So after defining everything, you can click on start recording and you will start the measurement. Now I have set the parameters for a sample measurements, and I'm going to carry out a measurement from minus 200 millivolt to 200 millivolt. The scan mode which I have decided to do today is dynamic scan with a scan rate of 10 millivolt per second. I'm not going to do ohmic drop correction, and as a dummy sample I'm using my test box with low Z setting. So with this, let's start the recording. So we start from minus 0.2 volt. The one thing which you should note here is that the y-axis is a log scale. And to save time, I will just skip to the end of this measurement. Okay, now the measurement is just finishing. And you see here that we have very nice IE curve. So you can save the measurement. I will not do it for today. And with this we come to the end of this video. So I showed you today that with IE option you can have different kind of scans. So we offer 3 different options, and by choosing different option you can define if you want to have your IE measurement only be with the Faradic response or Faradic and non-Faradic response. So with this, I thank you for your time and I will see you in the next video.